Last time you were absent.
No, sir. I was in the class last time.
Okay.
Yeah, it was just my mic was acting up a bit, so I couldn't really speak properly.
Okay. Now lecture number 13.
Uh-huh.
Last time we have completed structure of single bonded atoms, double bonded atoms, and today we will start triple bonding, right? Now lecture number 13, triple covalent bond. Triple covalent bond. Triple covalent bond. So first structure is 31, 32. 32 is nitrogen, thirty-three is C2H2, 33 is HCN. Here we have nitrogen triple bond, then carbon triple bond along with one carbon hydrogen bond. Then we have one hydrogen carbon bond and then triple bond N. This is all about the triple bond, triple covalent bond. Now, write a question which is very, very important. Nitrogen and phosphorus. Nitrogen and phosphorus both belong to the same group. Same group. Both can form NH3 and PH3. Respectively. Phosphorus can also form pH5, but nitrogen cannot. Yes. Can anyone explain why? Nitrogen can form NH3, not NH5. Phosphorus can make pH3 and can form pH5, but not nitrogen. Can anyone explain why? Yes, Hamza? Anyone?
Nitrogen can only like have 5 bonds or something like that. No.
Yes, Hamza? Now
Sorry,
listen.
sir. Yeah.
Can you tell me why Nitrogen can make pH3, pH5, but phosphorus, right? But not nitrogen. Nitrogen only form NH3, not NH5. Can you explain why?
Yeah, because of covalent bonds, right? The electrons, they need to share. It's like if you have three electrons, then nitrogen is in group 15. So it has like five electrons in its outer shell, and it can share like those electrons with H3. So with three
Same,
hydrogen
same,
molecules instead of five.
same for the nitrogen. Same for the nitrogen. Nitrogen also belong to the group 15. Five electrons are valence. So according to bonding, five valence electron means it can make five bonds. But in this case, NH5 is not possible, right? So examiner ask another question, right? Is that examiner ask another question? Nitrogen has only one valency. Plus 3. While phosphorus has plus 3 and plus 5. Explain why. Explain why. Now listen. Phosphorus has point number 1. Phosphorus has empty d orbital. Empty d orbital. While there is no d orbital, while there is no d orbital in nitrogen, point number 1. Point number 2, 3s electron of phosphorus transferred. I will explain. Now look at here. This is nitrogen. Nitrogen is 7. 1s2, 2s2, 2p3, 2p3. There is no d orbital. There is no d orbital in nitrogen because you have only 7 electrons. So no need of d orbital. We have d orbital after the second shell, right? From the third shell you have d orbital. So d orbital is not present in nitrogen. While in phosphorus, phosphorus is 15. 1s2, 2s2, 2p6, 3s2, 3p3. 1s2, 2s2, 2p6, 3s2, 3p3, and then we have 3d. This is 1s, this is 2s, this is 2p, this is 3s, this is 3p. In phosphorus, you have 3d. So 2 electrons in 1s, 2 electrons in 2s, 6 electrons are in 2p, 2 electrons in 3s, 3 electrons are in 3p. Now you can see that you have 3 unpaired electron in nitrogen. So hydrogen give 1 electron to make covalent bond. Hydrogen give 1 electron to form covalent bond. Hydrogen give 1 electron to give covalent bond. So NH3 is possible. Similarly, in this case, 1 hydrogen is given by the hydrogen another hydrogen electron. This is pH 3. Now look at pH 5. Now look pH 5. Now listen, if this 3s electron transfer to, if this 3s electron transfer to 3d, now you have 5 unpaired electron available for bonding. So hydrogen gives this electron to this orbital. Now it can make 5 bond, pH 5. Are you getting my point or not? So actually 3s electron of phosphorus transferred to 3d. Transferred to 3d. Now 5 electrons are available to share. Are available to share. Are you getting my point or not?
Yes, sir.
Yes, sir.
Now, as you know that my question was nitrogen can make NH3, phosphorus can make pH 3. Phosphorus also make pH 5, not nitrogen. The answer is that in nitrogen there is no 3d orbital. If there is no 3 orbital, it means you have only fixed valency +3. But in phosphorus you have empty 3d orbital. Whenever you have empty 3d orbital, 3s electron jump to 3d. Now this electron jump to 3d. Now you have 5 available electrons to make 5 bonds. That's why phosphorus can make pH 5 and pH 3. Yes, any question? Beta, any question?
No, sir.
Okay. Okay. So another question. So another reason, another question which examiner asked that why nitrogen has only one valency, phosphorus has +3 +5. The answer is that it has, phosphorus has empty d orbital. Now can you tell me the valency of iron and copper? Copper has +1 and +2 valency. Iron has +2 and +3. Explain why. Yes, why they exhibit 2 valencies. Yes, can you give the answer?
So will it be about the d orbital again?
Yes, yes.
So they both have an empty d orbital.
Empty d orbital, very good. Copper and iron both have empty d orbital. So whenever you have variable valency, the reason behind this multiple valency is due to empty d orbital. Now next question. Nitrogen and carbon monoxide both have triple bond. Nitrogen is inert. while carbon monoxide is reactive. Explain why. Yes, this is nitrogen. This is carbon monoxide. Yes. Can anyone explain why carbon monoxide is very reactive and nitrogen is inert?
So because of the d orbital.
Mm-hmm. Now you can see that nitrogen is non-polar because electronegativity of both nitrogen is same. So this is non-polar. Oxygen is delta negative, carbon is delta positive. So carbon monoxide is polar. Now you can see that in polar compound you have two sides, positive and negative side to attack. That's why carbon monoxide is very reactive. Are you getting my point or not? So this side is available for positive species and this side is available for negative species. So that's why it is very, very reactive. Negative species attack, positive species attack. So the answer is carbon monoxide is polar and nitrogen is non-polar. Carbon monoxide is polar while nitrogen is non-polar. Polar is more reactive than non-polar. Beta, are you getting my points or not?
Yes,
Yes,
sir.
sir.
Okay, beta, next question. Why C2H5Cl is more reactive than C2H6? Yes. Why this compound is more reactive? Yes. Why this
Because
compound
it's
is
a
more
polar.
reactive? Polar. Very good. Here we have negative charge, and here we have positive charge. This is polar, and this is non-polar. So the same answer. C2H5 Cl is polar and C2H6 is non-polar. C2H6 is non-polar. Polar is more reactive than non-polar. Polar is more reactive than non-polar. Any question?
No, sir.
No, sir.
Okay. A compound hydrazine. Hydrazine. Examiner asked many questions from hydrazine. So hydrazine is N2H4. N2H4. So molecular formula, N2H4. Empirical formula, NH2. Point number 3, compound is saturated. Compound is saturated. Saturated means either they have double bond or not. Yes, saturated means
Single bond.
Saturated means single bond. Single bond. Single bond. Single bond. Can anyone tell me the group number of nitrogen?
For group 15.
15. So it has the tendency to make 5 bonds. But here we have 3 bonds. 1, 2, 3. So how many electrons are left?
2.
2. Same for this nitrogen. So these are called lone pair. So whenever any element or atom form 4 bonds or 3 bonds with one lone pair, such element is called sp3 hybridized. This element is sp3 hybridized. I will explain why this is called sp3. This is, let's suppose this is S, this is P1, this is P2, this is P3. So this element is called sp3 hybridized. Now look at this nitrogen. This is S, this is P1, this is P2, this is P3. So this is again sp3 hybridized. So each nitrogen atom is sp3 hybridized. Each nitrogen atom is sp3 hybridized. Bond angle is 107. You have to memorize the bond angle. Bond angle is 107 degree. Shape is trigonal bipyramid. Sorry, trigonal pyramid. You have to memorize the shape. Whenever angle is 107, whenever angle is 107, shape is trigonal pyramid. I will explain all after the completion of hydrazine. Another important point is in hydrazine is that it can form hydrogen bond. You have studied hydrogen bond in O level, but in A level I will explain it again. So this is all about the hydrazine. You have to memorize all things. Now, real concept of bonding. 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 You have 4 steps, right? Number one, excitation. Excitation means, let's suppose you have carbon atom. Carbon atom is not willing to make 4 bonds. Excitation means try to convince carbon to make 4 bond is called excitation. Let's suppose carbon is not willing to make 4 bond. If you try to convince carbon to make 4 bond, such tendency, such situation is called excitation. Are you getting my point or not?
Yes, sir.
Okay, now listen. This is your first step. Let's suppose this is first process, excitation. 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 Jumping off 2s electron to 2p is called excitation. Now look at carbon. Look at carbon. Carbon is 1s2, 2s2, 2p2. Now you can see that in p orbital, you have only 2 electrons. You have only 2 electrons. Now my question is that, can anyone tell me how many electrons are available in carbon to make covalent bond? Yes. How many single electrons are available to share or to make covalent bond?
Sir, 2.
2. And carbon belongs to which group?
Group 14.
14. So it can make 4 bonds. But here carbon is not willing to make 4 bonds. Now what happened? This electron jumped to further. Now this electron is moved to further. Now can you tell me how many electrons are available?
Sir, 3.
Now count it again.
4, 4.
4. Now it can make 4 bonds. So this state is called ground state. In ground state, carbon atom is not willing to make 4 bonds. But in excited state, carbon can make 4 bonds. Let's suppose hydrogen 1, this is hydrogen 2, this is hydrogen 3, this is hydrogen 4. Here hydrogen can make 4 bonds. This is called excited state. Beta, any question which you would like to ask, right?
No, sir.
No, sir.
Okay. Alhamdulillah. So first step is excitation. Excitation means if an atom is not willing to make bond, so move its electron to d orbital or any further orbital and make 4 electrons available to make covalent bond. This is called excitation. Now second step is, this is first step. Second step is hybridization. Second step is so what is hybridization? First point, hybridization is mixing of orbital. Mixing of orbital is called hybridization. Mixing of orbital is called hybridization. For example, let's suppose you have s orbital. This is s orbital. This is px orbital. This is py orbital. This is pz orbital. So let's suppose point number 2, one s orbital and 3 p orbital. Px, Py, Pz are mixed together. Are mixed together and form 4 sp3 hybridized orbital. Now you can see that we have 4 orbitals, s, px, py, pz, all combine and form these 4 hybridized orbital. This is 1, this is 2, this is 3, this is 4. This is sp3. This is sp3. This is sp3. This is sp3. So 4 sp3 hybridized orbital. 4 sp3 hybridized orbital. 4 sp3 hybridized orbital. Tete, are you getting my point or not?
Yes, sir.
Yes.
Okay. So these are hybridized orbital. All are hybridized orbital. This is hybridized orbital. All are hybridized orbital. So these are hybridized. Hybridized means mixed orbital. Hybridized orbital. And these are unhybridized orbital. Unhybridized means without mixing. Unhybridized orbital. Angle between each orbital is 109.5 degree. And the shape is tetrahedral. And the shape is tetrahedral. And the shape is tetrahedral. So angle between two sp3 hybridized orbital is 109.5 degree. Shape is tetrahedral. Shape is tetrahedral. Now you can see that CH4 these are sp2 hybridized orbital, sp3 hybridized orbital, sp3 hybridized orbital, sp3 hybridized orbital. Now it has 4 hydrogen. So hydrogen is 1s. This is hydrogen 1s. This is hydrogen s orbital. This is hydrogen s orbital. So red one is carbon. This is carbon. And this is hydrogen. Hydrogen is S. So here we have sharing of electron. This is sharing of electron. So the angle between carbon and hydrogen orbitals 109.5 and shape is tetrahedral. So can you tell me how many types of bonding in it? Can you tell me how many type of bonding in this compound? Yes. There are 4 types of bonding. Bonding. First is sp3 and S. Second is again sp3 and S. Third is again sp3s. Fourth is again sp3s. This is sp3s. This is sp3s. This is sp3s. This is sp3s. Yes. Any question?
No, sir.
Sir.
Okay, Alhamdulillah. Now, next question is show bonding and hybridization of C2H4. C2H4. So how many carbon in C2H4? Yes,
Sir, 2 carbon.
2 carbon atoms. So first step is same. First step is same. Excitation. Second step is hybridization. Second step is hybridization. Second step is hybridization. So again in ethene, one s orbital, but in ethene, one orbital is not willing to make, one p orbital is not willing to make hybridization or hybridized orbital, and one p orbital is not willing to participate in covalent bonding. So PZ is not willing to make bonding. Now 3 orbitals mix. One S, second is PX, third one is PY. So here 3 sp2 hybridized orbitals are formed. Why not 3? Because there are only 2 p orbitals involved in bonding. So 1 p orbital, px, py, and pz. So this pz is not willing to make hybridized orbital. Now look at it again. Now 1, 2, 3. Each is sp2 hybridized. This is sp2. This is sp2. This is sp2. But one orbital is remain unhybridized. This one. So now you can see that this is unhybridized. This is unhybridized. This is unhybridized. While all these orbitals mix together and form 3 hybridized orbitals. Now the angle is 120 degree. This is hybridized orbital. Hybridized orbital. and this one is unhybridized orbital. Unhybridized orbital. Now next point. Beta, are you getting this point or not?
Yes, sir.
So we have sp2 hybridized orbital. Now look it again. In ethene, you have 2 carbon. Now look at this is each one is sp2 hybridized. This is sp2. This is sp2. This is sp2. This is ethene. Now you have another carbon. This is again sp2, sp2, sp2. You have 4 hydrogen. This hydrogen, another hydrogen, another hydrogen, another hydrogen. So this is s orbital. This is covalent bond, sharing of electron, sharing of electron. Now can you tell me how many unhybridized orbital? Beta, how many unhybridized orbital?
Sir, I didn't
2,
understand.
right?
We do.
Beta, how many unhybridized orbital in each carbon?
So 2, right?
2, exactly 2. Can you repeat your question?
Sir, I didn't understand how did you get the structure, this sp2 stuff.
Okay, okay. Again, listen. You know that each carbon has 3 or hybridized or unhybridized orbital. Now look at here. 1s, this is px, this is py, this is pz. So 4 orbitals are available for the bonding. In sp2, you have 4 available orbitals. But pz is not willing to make to overlap, right? And pz is not willing to hybridize. pz is not willing to mix. That's why this orbital is remain unhybridized. All 3 mixed and form sp2, sp2, sp2 hybridized orbital. In this case, you have 3 hybridized orbital and 1 unhybridized orbital. Are you getting my point or not?
Sir, how did you know pz is unhybridized?
Because whenever you have 1 double bond, pz is unhybridized. When you have triple bond, py and pz are unhybridized. Whenever you have single bond, all px, py, pz hybridized.
Okay, sir, I got it now.
Okay, alhamdulillah. Now, this is ethene. Again, you have 1 unhybridized orbital. This one is unhybridized orbital. So this is unhybridized. Unhybridized. And this one is hybridized. Now you can see that these unhybridized orbital interact with each other. These unhybridized orbitals interact each other. Interact with each other. Now you can see that this interaction. These can interact. Now see it again. Unhybridized orbital interact. These unhybridized orbital interact. As a result of this interaction, double bond is formed. Are you getting my point or not?
Yes, sir.
Unhybridized interact, hybridized form strong bond. Unhybridized form double bond. Now tell me few answers, right? Angle between each hybridized orbital is, yes, angle between two sp2 hybridized orbital is, yes, tell me.
120.
120 is 120 degree, correct. Point number 2, shape is trigonal planar. Shape is trigonal planar. Shape is trigonal planar. Next, each carbon has one pz unhybridized orbital. Unhybridized orbital. Now, unhybridized orbital forms single bond or double bond? Yes,
The double.
double bond. Unhybridized orbitals form double bonds, and hybridized, yes, hybridized orbitals form
Sir, single bond.
always single bond. Always single bond.
Sir,
Yes,
do we have to memorize these values of the angle?
yes, you have to memorize. I will make a chart after the completion of the hybridization.
Okay, thank you, sir.
Okay, next is how many bonds? So there are, I think, 6 bonds. Yes, one is sp2 sp2. This one, this is sp2 sp2. Yes, second one is
Sir, sp2s.
sp2s. Third one, you have 4 sp2s. 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 And the last one, this is unhybridized pz. This is unhybridized pz. Yes, can anyone tell me the sixth bond? Yes, can anyone tell me the sixth bond?
PZ with PZ.
PZ and PZ, very good. Sixth bond is PZ and PZ. PZ and PZ. All are single bond. This PZ and PZ is double bond. Double bond. Now we can able to make the ethene molecule like this. sp2, sp2. This is S. This is S. This is S. This is S. This is PZ. This is PZ double bond. S. Oh, sorry. Hydrogen. 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 This is sp2. This is sp2. This is PZ. This is PZ. This is S. This is S. This is S. This is S. Are you getting my point or not?
Yes, sir. Getting.
Yes, sir.
Okay, Alhamdulillah. Now the last is same question. Show bonding and hybridization of C2H2. Again the same procedure. Excitation. Same. And then hybridization. Then hybridization. Then hybridization. Now one s orbital and one p orbital px are mixed together and form two sp hybridized orbital. Now py is not willing to make bond, pz is not willing to. So how many unhybridized orbital? Yes, beta, how many unhybridized orbital?
Sir, two.
Two. It means you have two double bonds. Two double bonds means you have triple bond. One single bond and two more bonds. So two more bonds means triple bond. Whenever you have two unhybridized orbital, you have triple bond. Whenever you have one unhybridized orbital, you have double bond. Whenever you have no unhybridized orbital, it means all single bonds. Getting my point or not?
Yes, sir.
Now, this is hybridized orbital, and these two are unhybridized orbital. This is PZ, unhybridized, this one is PY, unhybridized, and the red one is hybridized orbital. Hybridized orbital. These are SP, SP. Yes. So angle between sp3 hybridized orbital is 180 degree. 180 degree. Shape is linear. Shape is linear. Shape is linear. Now look at the structure. So you have carbon-carbon triple bond along with one hydrogen. So we have another. So you have two hydrogen. This is S of hydrogen. This is S of hydrogen. So you have two unhybridized orbital. So this one is interact with this. This one is interact with this one. So you have two bonds, either upward or either downward. Either upward or either downward. So angle is 180 degree. Shape is linear. So can you tell me how many bonds are there? Yes. Oh, how many bonds?
So 3.
5 bonds, right? 5 bonds.
Oh, okay.
Yes. Number 1. Yes, number 1.
PLS.
SPS.
SP. Correct. Number 2.
SPS.
SPS. Number 3.
And can we consider SPSP?
Yes, SPSP. Yeah, we have done one. First one is SPSP. So third one is again SPS. Fourth one is PZ. Fifth one is PY. Let's suppose this is PY. This is PY. This one is PZ. This one is PZ. So there are 5 bonds. Okay, do you have any question?
No, sir.
No, sir.
No, sir.
Okay. Next is shape, hybridization, and geometry. Shape, hybridization, hybridization, and geometry. And geometry. Now, number one. Number one. Carbon dioxide. We have already studied the shape of carbon dioxide. Can anyone tell me the bond pair and lone pair in it? In the central atom carbon? Yes, can anyone tell me the bond pair and lone pair? Double bond considered as one.
So bond pair will be 2 and lone pair also 2.
No, there is no lone pair on carbon. Carbon belongs to group 4, group 14. So all 4 bonds are involved. So there is no lone pair. So whenever you have 2 bond pairs, 0 lone pair, geometry is linear. Geometry is linear. Angle is 180 degree. Now question number 2. CS2. 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 Again, you have 2 bond pair, 0 lone pair, linear. Number 3, HCN. Number 3 is HCN. HCN. This is H. This is HCN. How many bond pair?
So could you go up for a second?
Yes, yes.
Okay, thank you.
Yes, can anyone tell me the bond pair in HCN? We are discussing central atom carbon. Can anyone tell me the around carbon? How many bond pairs are there?
Sir, 2.
2. So 2 bond pairs, 0 lone pair on central atom carbon. That's why shape is again linear. Now number 4. BeF2. Now can anyone tell me the group number of beryllium? Yes, can anyone tell me the group
Group 2.
number of
Group
2?
2.
Group 2. Group 2. Group 2. So how many bond pair?
Sir, 1
1 bond pair.
or 2.
two bond pair.
But sir, isn't
This
that a
is
single
bond pair.
bond?
Yes, this is called one bond pair. This is called second bond pair. So two
Oh.
bond pair, zero lone pair, linear angle is 180 degree.
So single bond and double bond both are pairs.
Yes, single bond, double bond, triple bond, all are considered as one.
Okay, okay.
Now hybridization. Now look at the technique. This is called DI. TI. This is called finger method. Finger method. Now you can read like this. If I mark this line, you read S. For another line, you read P1. For another line, you read P2. For another line, you read P3. So the hybridization is SP3. This is called finger method. Now anyone read along with me. This is first one. This is called S. This is called P. So the hybridization is SP. This is called finger method. Hybridization is SP. SP hybridization. Now read for this carbon. Yes. SP. Again SP hybridization. This carbon is SP hybridized. Now can anyone read for this carbon?
Sir, SP1.
Yes. S and this is again P. So hybridization is SP. Again read for this SP. This is SP. SP.
Sir, when will it be SP2 or SP3?
Yes. Further, inshallah, we will do. So all are SP hybridized with bond pair. Whenever you have SP hybridized, angle is 180, shape is linear. Now number 5. Now number 5. BF3. Now can you tell me the group number of boron?
Sir, group 13?
Yes. Group 13, it means it can make 3 bonds. So how many bond pairs?
Sir, 3.
3 bond pairs. How many lone pair?
0.
0. Now can you tell me the hybridization? Now read with me. S, P1, P2. This is sp2 hybridized. Are you getting my point or not for the hybridization?
Yes, sir, getting.
sp2 hybridization. Whenever you have sp2 hybridization, angle should be 120 degree and shape is trigonal planar. Trigonal planar. You can write with the double N. Trigonal planar. 5/5 trigonal planar. Now question number 6. AlCl3. Yes. Yes, aluminum belongs to
Group 13.
group 13. So it means it can make 3 bonds. So how many bond pairs?
3.
Bond pair 3. How many lone pair?
0.
0. Angle should be hybridization S P1 P2. Hybridization is sp2. Hybridization is sp2. Angle is, whenever sp2, angle is 120 degree. Shape is trigonal planar. Trigonal planar. Trigonal planar. Now next, number 7. SO3. Yes, sulfur group number
16.
60. It can make 6 bond. So 1, 4, 5, 6. So can you tell me the bond pair?
So it's 3.
3 bond pairs. Lone pair 0. Hybridization sp1 p2. Hybridization is sp2. Whenever you have hybridization sp2, angle is 120 degree. Trigonal planar. Now question number 8. Question number 8. Nitrate. Nitrate. Now can anyone tell me how many oxygen atoms are there?
So it's 3.
3. So can you tell me the charge on nitrate?
-1.
-1. It means you have one single bond. One single bond between nitrogen and oxygen. Right? So how many oxygen are left?
2.
2. So 2 oxygen. Nitrogen oxygen bonds are double bond. As we have discussed this one in yesterday class, right? In the previous class, we have discussed the shape of nitrate. So this is nitrogen, one single bond, because you have -1 charge, 2 double bonds. Now tell me the bond pairs.
So it's 3.
3. Lone pairs on central atom.
So it's 0.
0, because nitrogen belongs to group 15. In fact, it can make 5 bonds. So 1, 2, 3, 4, 5. So lone pair is 0. So hybridization is sp1 p2. Hybridization is sp2. Whenever you have sp2, angle is 120 degree and the shape is trigonal planar. Trigonal planar. Now next is carbonate. Yes, how many single bond?
So 2.
2 single bonds. 2 single bonds. And the remaining oxygen is 1. So 1 double bond. So can you tell me the bond pair
3.
and lone pair?
0.
0. Hybridization,
sp2.
angle and geometry,
120 degrees and diagonal planar.
120 degree triangular planar. Very, very easy. Now next, number 10. Number 10. Nitrate, carbonate, sulfate and phosphate are left. Now, number 10 is NCl3 or sulfate. Sulfate. So how many single bonds?
2.
2 single bonds. And how many double bonds?
2.
2. So this is sulfate. So how many bond pairs?
4.
Bond pairs 4. How many lone pairs?
0.
0, because 1, 2, 3, 4, 5, 6. 0. Now can you tell me the hybridization?
So sp3.
sp3. This is S. This is P1. This is P2. This is P3. This is sp3. Angle is, whenever you have sp3, angle is 109.5 degree. And the shape is tetrahedral. Tetrahedral. Now number 11. Phosphate. Phosphate. So how many single bonds?
3.
3 single bonds. Three single bonds. So, in which group phosphorus lie?
So group 15.
Group 15. So it can make 5 bonds, right? 1, 2, 1, 2, 3, 4, 5. 5 bonds. Now tell me the bond pairs and
4.
hybridization. Yes, bond pair 4. Lone pair
0.
on phosphorus 0. Hybridization
sp3.
sp3. Angle whenever
100.
sp3 109.5 and tetrahedral. Tetrahedral. Now shape number 12. CH4. Yes. Four bonds. Yes, how many bond pair and lone pair?
So 4.
What is the hybridization?
sp3.
sp3. Whenever you have sp3, angle is 109.5 and the shape is tetrahedral. Okay. So in the next class, do you have any question?
No, sir.
No.
Okay.
Okay. These two chapters are very lengthy, atomic structure and chemical bonding, right? After these two chapters, we have kinetic, we have redox, we have states of matter, very, very short topics, right? Then we have energetic, equilibrium, only numericals are there. Then we have moles, only numericals are there. right? So now after the completion of this chapter, we have basically have numerical chapters, right? Very, very small chapters. Atomic structure and chemical bondings are very lengthy. Okay, do you have any question?
Sir,
No, sir.
Yes, yes.
when will we solve past papers for the first chapter?
Inshallah, after the completion of second chapter, I will start past paper, right? After the completion of the second chapter, okay? Because we will do past paper in combo, right? Examiner ask few questions from atomic structure and few questions from bonding and make a question. So after the completion of two chapters, atomic structure and chemical bonding, we will start past paper, right? But you can see that during the lecture, mostly I use past paper question. You can see. You
Yes,
can
sir.
see 9701. Yes, here. So we have already started the past paper question. 9701 October November 2015. So basically we will start, right, separately past papers, right,
All right, sir.
after the completion of first two chapters, right?
All right.
And we will do past paper in separate class, right? Not in regular classes, right? I will conduct extra class, right? I have many local students and I try to give the whole lecture in Urdu as well as in English, right? This is my private class. This will be my private class and extra class. Are you getting my point or not?
Yes, sir.
Okay. So these three classes only for theory, and for past paper I will take extra class. Okay. Any question?
No, sir.
No, sir.
Allah Hafiz.
Allah Hafiz.
Lapis.
No, sir.
Allah Hafiz.